everyone. This video is made by Saaid Pirzada as part of the final assignment of Foundation Design course from Skyfi Labs. The Foundation Design Project online course video tutorials from Skyfi Labs were used to complete this project. Here we will be designing a matte foundation for the tall building which we have already created for the previous video assignments. The link is in the description. Here we have the given problem statement in which we are having 16 columns, each of which is spaced 6 meters apart. The safe bearing capacity of the soil is 300 kN per meter square and the allowable settlement is 1 centimeter. The given table shows the column name, dimension of the column, the dead and live load acting on it, and the materials to be used respectively. Now we will calculate the subgrade modulus from the following formula, which comes around 30,000 kN per meter cube. After that, we calculate the column strip width by the following formula, which comes out as 4.5 meter. However, there is no concrete provision for the given strip width, so we will be using 4 meter column strip width. The matte foundation will be extended 2 meters on all sides of the building plan, and hence its length and breadth will be 22 meters each. Now go to Safe Software, click on File, New Model, and in the design code select IS456. In the design preferences, click on Modify/Show and go to Minimum Cover Slabs. Enter the values for the clear cover at top and bottom as 50 millimeters each. In the preferred bar size, select 22 and click on OK. We will be designing the building slab of 18 by 18 meters from the grid only option. So click on grid only and enter the values as shown. The grid has been formed. Now go to Define and select Materials. Here we will define the concrete and the steel material. As you can see, I have already defined those two materials. While defining the concrete material, make sure to keep the parameter values as shown. Similarly, for the steel, make sure to keep the parameter values as shown. Now go to Define and select Slab Properties. Here we will define the matte footing and keep the parameters as shown. Again go to Define and go to Column Properties. Although there are 16 columns, but actually there are only two kinds of columns. One is the first column of 500 cross 500 dimension, and the other is column of 600 cross 600 dimensions. So keep their parameters as shown. Similarly, for the second column type, keep the parameters as shown. Now go to Define Soil Subgrade Properties, and here we will define the soil subgrade property by entering the values as shown. Again go to Define, and this time we have to make sure that the correct load patterns are there. So that dead and live load has been defined, so that is correct. Next we'll go to Define Load Cases. Make sure that for both dead and live load, the linear static load case is kept. Again go to Define, click on Load Combinations, and here we will define two load combinations, combination 1 and combination 2. Make sure to enter the parameters as shown. Click on OK. Now click on Draw and select Slab/Areas. Make sure that the matte footing has been selected. Now click on the first corner point, then the next corner point, then the next corner point, then again the next corner point, and finally click on the first corner point. Close the box and press Escape on your keyboard. This is the slab for the building plan. Now we'll expand the slab by 2 meters on all sides. Click inside the slab and make sure that 1 areas and 4 edges selected has been displayed. Now go to Edit, Edit Areas, and click on Expand/Shrink Areas. Here we'll expand the slab by 2 meters, which is equal to 2000 millimeters. So click on OK. So the slab has been extended by 2 meters on all sides, and this is the footing area. Now we will add columns on this footing. For that, go to Draw and click on Draw Columns. Here we will be using the first column type, which is 500 cross 500 millimeters, and then we'll keep property below as none and property above as column 500 cross 500. Height below we'll keep as 0 and height above we'll keep as 2. Now we'll draw the 500 cross 500 columns on the footing. Now draw the columns of dimension 500 cross 500 on these points as shown. After drawing these columns, we'll draw the second type of columns of dimension 600 cross 600. For that, first select the second type of columns and draw these columns on the points as shown. After drawing the columns of the second type, close the box and press escape on your keyboard. Now we will draw the design strips. For that, go to draw and click on draw design strips. Enter the values for the strip width as 4 as we have calculated earlier. The strip layer A will be drawn in the X directions 4 times through the column centers as shown. After drawing the first strip layer, right click to exit drawing the first strip layer and proceed to draw the other layers in the similar way. Right click again to exit and then again draw. Repeat for the last strip layer. After strip A layer has been drawn, now we'll draw the strip layer B. These will be drawn in the Y direction again through the column centers and will be totally 4 in numbers. Now we'll draw the first strip B layer to the column centers. Right click to exit and again repeat for the others. After all the strip layers have been designed, close the box and press escape on your keyboard. Now select the foundation area by clicking inside it. Verify the selection and go to Assign, Support Data and select Soil Properties. Select Soil 1 and click on OK. The soil properties beneath the foundation have been applied. Now since each of the column carries a different dead and live load, we have to individually select these columns and then assign the dead and live load respectively. Select the center point of column 1, go to Assign, Load Data and click on Point Loads. Make sure the dead load has been selected here. From the table we can see that the column 1 has a dead load of 1850 kN. So enter the value as 1850. For X and Y dimension, enter the values as shown. Click on OK. Now the dead load on column 1 has been applied. Again select its center point, verify the selection, again go to Assign, Load Data, again select Point Loads. This time select the live load option. From the table we can see that the live load value is 797.6. So enter the live load value as 797.6 and click on OK. Now on column 1 both the dead load and live load have been assigned. Similarly select the center points of each of the column and assign their corresponding dead and live load. Now after all the dead and live loads have been assigned to the respective columns, right click on any column center, go to loads to check for the values of the dead load, live load and the size of the load. Right click inside the footing area and go to design and change the rebar material to HYSD 500. We need not change the rebar material for the column as it has already been assigned with respect to the rebar material of the footing. Now we'll change the rebar materials for all the design strips in the X and Y direction. So right click on any of the strip, go to design and change the rebar material to HYSD 500. Repeat this for other strips as well. Now we have assigned the rebar materials to all the design strips. Now we'll proceed with the analysis of the footing. Go to Run and click on Run Analysis. Save the file if you haven't already saved the file. The displacements in the various regions of the footing is shown. Now again go to Run and click on Run Analysis and Design. After it is done, go to Display and click on Show Punching Shear Design. We can see that the punching shear ratios for many of the columns are greater than 1, but our objective is that they should be less than 1. So now unlock the model, go to Define, Slab Properties, Mat Footing, and click on Modify/Show Property. Increase the thickness of the footing to 1200 millimeters and click on OK. Again click on Run and select Run Analysis and Design. Again it shows the displacement values in the various regions of the footing. Now again go to Display and click on Show Punching Shear Design. We can see that all the punching shear ratios are less than 1. So this is the final design of the footing under which the design check has passed. Now go to Display and select Show Strip Forces. We can toggle between various options to view different results. For example, we'll be looking at the moment, so click on Apply. It shows the various moment values in both the layers. Again go to Display and this time select Show Slab Design. Make sure to select the Impose Minimum Reinforcing option. You can either select to view the results for layer A or B or both. And click on Apply. It shows the reinforcement intensity in both the layers. Again go to Display and this time click on Show Slab Forces/Stresses. Choose any of the options and then click on Apply. It shows the maximum moment values here. Again go to Display and this time click on Show Crack Widths. Again choose any of the option as per your choice and click on Apply. It shows the various crack widths in the slab bottom face. We can see that these crack widths are in the range of 10 to the power minus 3 from this color code. So these crack widths are negligible. Similarly, select slab top face and click on Apply. Here also the crack widths are in the range of 10 to the power minus 3 and hence are negligible. Click on Close. Now we will generate the detailing reports and view the results. Go to Run and click on Run Detailing. Mark all the 3 options and click on OK. Wait as the detailing diagrams are generated. Now expand the Drawing Component Views option, expand the Slab Views option, and double click on the rebar table. The rebar table shows the different bar dimensions used, the lengths and the number of each bar dimension. Similarly, double click on the rebar schedule and the bill of quantities to view the summarized reports of the different bars and their quantities. Now expand the individual slab views and expand the mat 1. Double click on the rebar plan. The rebar plan displays the overall layout of the rebars of varying dimensions in the footing plan. Now double click on the reinforcement profile for layer A and B. The reinforcement profile option displays the profile of the reinforcement area distribution in the 2 strip layers. Now similarly double click on the section 1 and section 2. The section 1 and section 2 option displays the rebar plan in the elevation section in both the directions of the footing. Likewise, we can select the other options to view the rebar plan in different forms. Thanks for watching.